Hello, everyone. I'm Daniel. I'm on the engineering team at Hyperlane. You probably know Hyperlane already if you've looked at cross-chain anything. So we do general message passing, and we do token bridging. We do that permissionlessly, which means we allow people to self-deploy. And so at the hackathon today, you can do and build on top of any of that. But since intents are one of the most interesting things happening nowadays in the world of crypto, I thought it's most relevant to look at how Hyperlane can help you build intents on top of the existing deployments we have. And so the agenda for today is to look at how intents compare to message passing, message-based token bridging, and then see how intents can really benefit from Hyperlane's architecture. And based on that, we'll see what kind of bounties you're able to build. So let's start by looking at message-based token bridging. And at core, Hyperlane is this general message passing protocol. In practice, all of these message passing protocols are used just for token bridging. That's literally 99% of the volume. And warp routes are Hyperlane's take on token bridging. They're built on top of general message passing, and it's a fully open architecture and framework. So they work with any token standard, and they work with any sort of security module. We call that modular security, and it means that if you integrate with Hyperlane, your protocol is future-proof in terms of enabling you to upgrade your security as better models become available, such as zk-Lite clients. And so let's just look at how powerful warp routes are. I'm going to show you a demo. OWL protocol built a UI for self-deploying a warp route. It takes 60 seconds to do the deployment, and then it just works. You don't need to run any infra. You don't even need a wallet to use OWL protocol because they have account abstraction. And it's pretty much a one-click deploy, and then you can start bridging via Superbridge. It's this one. Yeah, so they have like this website interface where you can select the tokens that you want to connect using the warp routes. And so you get to connect the origin chain. Let me start the demo. You get to select the origin chain and then the token you want to bridge from that chain. In this example, they're going from the Sepolia testnet, bridging native ETH to some destination chain, minting synthetic ETH. On the right-hand side, you just set the token name and symbol for the synthetic. But the warp routes allow you to connect collateral tokens as well, which means you don't need to mint synthetics every single time, like to wrap assets. You can just provide liquidity and allow people to lock and unlock, essentially. And so in this example, the warp route connects 3 chains, native, ETH on Sepolia, and then synthetic on the other 2. The user clicked deploy, and then the transactions are out on all 3 destination chains. You see the live status there, and you didn't even need a wallet interaction because they're account abstraction. And the really, really cool thing about this is that after the deployment is done, you get a configuration with deployment artifacts of the warp route, which you can then use in the Superbridge app, which is a bridging interface. And you can start bridging straight away. You have a UI with the bridge you just deployed. And you then select your origin chain, the token you want to bridge. And you're good to go. You have a live token bridge. The only thing remaining to take this to production is to move ownership of these contracts to something very safe, because it's currently owned by the hotkey in account abstraction. All right. And so moving on, we've seen how Hyperlane has made token bridging based on messages very, very easy to do. Let's look at what intents are. Hyperlane is building on top of that. An intent is really a user expressing their wish to chain. They do so by sending a transaction on the origin chain. Then there's an off-chain actor called usually a filler that will notice that intent and then perform an action on the destination. Usually this means the user wants to bridge some token from an origin chain to a destination chain. And so because the filler will have balance on the destination, they will send those funds to the user immediately. Yeah, and then the steps are essentially that. Number one is you sign an order that gets sent on chain, on the origin chain. There's a settlement contract that takes the user's tokens into escrow. After tokens are in escrow, the filler can send funds to the user on the destination chain. And then the last step is to reimburse or pay the filler with the tokens that were held in escrow from the user. And so, you know, people who build intents almost behave like, oh, you don't need in order to do cross-chain actions. But the truth is that for settlement purposes, you absolutely need general message passing because the filler needs a way to prove that they sent funds to the user on the destination. And so, yeah, general message passing will always be required. And the question is, how can we do that? How can we make that easier? Just found it interesting that over time, clearly intents have gained a lot of popularity. Now they're around 50% of cross-chain volume compared to message-based token bridging. And let's look at some facts about message-based token bridges, which are warp routes, and intents. So warp routes are slow because they need to wait on finality on the origin chain. If you don't wait on finality, a reorg could occur, and so the tokens you sent initially are then given back to you because it's as if that transaction never happened. So you kind of end up double spending because you receive tokens on the destination and you get them back on the origin as well. But they're very easy to bootstrap. Like you've seen the demo, it takes around 60 seconds to deploy. You don't need inventory in order to fill users on the destination chain because in most cases you mint synthetics. And it works between any chains because of that reason. And what's more, execution is guaranteed because you can, even if there's no relayer to send your message to the destination chain, you can relay your own message that will, cause new tokens to be minted. So that's pretty convenient. But then they're slow, right? And that's where intents really shine because the filler, in many cases, doesn't even need to wait on finality. The fee you pay to the filler to do the cross-chain intent execution usually acts as this reorg insurance almost. So basically, on average, or reorgs happen very, very rarely. So it's very safe for fillers to assume that over time the fees they get are greater than any funds that they may lose because of a reorg. So this is the big, big benefit of intents, and it's why they're taking off. But they're much harder to bootstrap because you need fillers, and those fillers need inventory. And they need inventory either in any token that you're trying to bridge cross-chain, or they're going to need to take their, say, funds and then swap them and only them send them to the users. I'm not sure what happened here. There you go. Cool, let's keep going. Yeah, and as I said earlier, we still need general message passing bridges for settlement. But then you also need them to mint inventory. Like if a token doesn't already exist, it cannot be held by the filler, then it's impossible to do intents. And then also, as a filler, if all users go from one chain to the other, like bridging is very imbalanced, you may end up no longer having enough funds to fill orders. So you need to rebalance your inventory. And you also need likely like a general or traditional token bridge if there's no other filler to allow you to move your funds. And so as I said, intents today are generally cheaper and faster, so more convenient than token bridging. It gives users a better experience of using the app. But the bad is that like intents protocols today, they roll their own messaging protocols and they tightly couple security. So I think a very common use case is to use like some sort of optimistic oracle that proves that settlement happened on the destination chain. And then, yeah, because of that, you have these intents protocol that do both intents, but then they also do token bridging. So they're kind of spreading themselves rather thinly. And obviously, they can't do everything best. They should focus on what distinguishes them from their competitors. And as a result, intents are usually limited to a handful of chains. And this is where basically we started thinking about why not use a general message passing protocol to settle intents instead of building your own, so you can focus on the intents layer. And besides that, like basically just allowing us or other message passing protocols to handle settlement for you. What Hyperlane really gives you and where it really shines is that it has modular security, which means that different sums can be settled with different security mechanisms. So say there was just a single order of $1 that you're trying to settle. That doesn't really warrant the highest level of security. You can go with a cheaper method, like maybe some multisig or some trusted oracle that tells the protocol, yes, $1 was really sent by a filler to this user. You can now pay the filler on the origin chain. So as a protocol, you can have these sort of criteria. And this, in turn, makes it cheaper for fillers to operate because, I guess a less trusted security model will be cheaper to verify. So fillers will have to pay less in fees to use the intents protocol. And in the end, all this means user get lower fees. So kind of like to think about all the stakeholders in an intents protocol. The protocol itself gets to pick its trade-off that best matches the settlement speed they want to achieve and the security and the cost for different kind of sums that end up being bridged. And you can focus on attracting users, making it easy for solvers to integrate. Then for solvers, again, like you get kind of abstracted from many of the complexities of message passing, and you can focus on what you do best, which is manage your inventory, index new intents so you can fill them quickly, and then including your transactions. And then in terms of users, overall you get better quotes because settlement can happen very dynamically based on the amount being bridged, so it can end up being cheaper. And it's a virtuous cycle because you start off with better UX. This attracts more users, which generates fees and volume, and this leads to more competition, which attracts solvers. And because there's fiercer competition between solvers, you get lower fees, which attracts more users, and so on. And with that in mind, we started developing an open source intents framework where we already have a solver that's live. We have basically a CLI that you can use to spin it up, contracts that you can deploy where users can send their intents. And actually, I have a demo to show you exactly with that. I'm not sure how good we're at time, but you just spin up the solver and it indexes the origin chain. It will look for intents as they're being broadcast. And then if the solver has enough balance on the destination, it will fill the user's order, essentially. And we're trying to make this, 7683 compliant. There is no 7683 intents protocol live in production today, and we're trying to, ideally turn this into an industry standard that other intents protocols can build on top of, and then add their solver and so on. Yeah. So as you can see, the intent was noticed. Then the order was filled on the destination chain, and then the final step is settling it, which means the filler gets reimbursed on the origin chain, and then there's some transactions there. And just because we're very short in time, let's get to the bounties. So you can build anything. The best projects will get the prize out of the 10K pool. If you don't have any ideas, what I can suggest is basically two main areas. One is account abstraction, and the other one is intents. In terms of account abstraction, Hyperlane supports interchain accounts, where you can control accounts on remote chains from like some origin chain, and you can have balance, you can initiate authenticated cross-chain calls, but like smart wallets today aren't integrated with that. And then, the other thing you can do is build around intents. So the current framework we built only supports token bridging, but you can have call data-based intents. So basically, cross-chain calls. You can build a request for quote system to have better, pricing discovery of how much it costs to send an intent. In the current version of the framework, users have to kind of estimate or assume how much it will cost. You can also build a UI for this intent system that I just showed you. And really, I just invite you to come chat to us at the booth for more, because there's tons of things you can build, and it's all open source, which makes it way easier.